We're going to go ahead and record. They've got an updated Zoom. I don't know if you guys noticed that. All right, so you should be able to see closed captioning for those of you that need the additional accessibility. And let me share, I'm losing my hearing and my sight, comes with age. So I often watch TV with closed captions. Yeah, and it was updating. That's why I'm late on top of everything else. As I was loading us in, it decided to update. Okay, so first thing I want to share with you guys is let's take a look at the household products that I have sitting here. So I have some dirt, I have some sponges, some water, I have a jar, an empty jar, and I have vinegar and white vinegar, and I have baking soda. And so basically what we're going to do is we're going to demonstrate a little bit about what you guys have been studying. We're going to tie in week 2, which was the pHs, and how you can test for acid rain, you can test for not contamination, but acidic soil or soil that is more on the alkaline side. So those are things we're going to review today to kind of give you an understanding of how what you did in week 2 actually works here in week 4. The other thing that I want to share with you is your individual project and how to complete it. I did send lessons, by the way, on that, but you should have found them via email. And if you didn't get them, please let me know. In the meantime, let's take a look at this week's expectations or the assignment for this week. So I'm going to go ahead and switch screens. Hopefully you'll see the right screen. So you guys should be looking directly at the classroom. Is that correct?
Yes.
Let me know if it is. Okay, excellent. All right, so here is the upcoming live meetings or the meetings that we're participating in right now. And so if you decide that you aren't able to view it right now or any of the previous ones, because remember, the very first week is worth extra credit, week 2 is voluntary, and we're in office hours / IP introduction to week 4. And this will move down to the archived meetings within an hour after our lesson. So here are the assignments again, and we are on individual project 2. It is due, individual project 4, and it's due on 2/12. And so let's take a look at the details. So very similar to what we did in week 2, you are going to be going on a virtual field trip with Marcia, the Martian, and your lab report is right here. It can also be found within the lesson itself. We're going to talk about pHs, soil infiltration, runoff, etc. And like I said, if you can't download this particular one, I did email you both a text copy and an attachment as a Word attachment rather than a Google Docs. So this is basically your lab report, and you are going to be going to different lakes. And you're also going to be looking at, different environments, and you're going to be looking at how well the water is infiltrating these particular environments, vegetation, mountain, or soil. So if we take a look and we jump into the individual project, okay, click on that. So here is the lab, and we're going to go ahead and read through. you do not have to actually leave to go collect soil samples anywhere. Everything is virtual. So this is basically our soil infiltration and runoff. I don't know what's going on with my computer. Okay, and so we're going to basically do some virtual tests. We're going to gather information, basically research, and you're going to calculate what water evaporation is in the atmosphere after 1 inch of rainfall. And then you're going to convert the percentages to gallons of water. And again, if you forgot to download the lab report, you can open it right here as well. See it highlighted. So we're going to go through and we're going to look at site 1, 2, and 3. While you're looking at these sites, it's very important that you actually write down information and anything that's descriptive. So this is a vegetation site. So what you're looking at here is everything is covered with green. It's green. And what kind of hills does it have? Sloping, flat, etc. And these are the percentages that you're going to write down. Runoff is 10%, shallow and deep infiltration are both 25%. So we'll come back to our lab here. And since we visited site 1, which was vegetation, we're going to go ahead and put 10% in here. We're just transferring the information to make it nice and neat and organized. 25%, 25% here. And how do we calculate 100%? Remember, 100 is part of 100. So if you have 25, 25, and 10, you've got 60 out of 100. So to calculate this, you're basically going to subtract the 60 and from 100, and you'll get 40%. And we show that right up here for the example. So you had 60% of water that's accounted for. The evaporation is the difference between 100 and your total amount of rainfall. So for every inch of water, okay, so if we have 100 inches of water, 60% is absorbed, 40% is evaporated. So now you're going to do the same thing again. You're going to return and you're going to go to site 2. Make sure that you follow the instructions here. We just kind of went over that. And now in site 2, we're going to do the same thing, but I'm not going to do it for you. I want you guys to do it. Again, look at the surrounding scenery, mark it down. Is it rocky? Is it bare, etc.? Okay, and once you do that, it'll take you back and it will have you go to the next site. And so you're going to get that information. I'm going to have to play it to get it to do what I want. So then you have 60, 10, and 5. And they're in the same order: runoff, shallow, deep, and so on. Again, we're showing you all the different areas, what it looks like, rocky, and so on. Make sure you write these descriptive words down. Okay? And so after you do that for all 3 sites, then you're going to take this information and you're going to put it into this formula. So this formula basically converts percentages to gallons. And so our formula here, which is 0.623, we're going to take shallow infiltration and we're going to take the formula, which was 0.623, and we're going to multiply it by 10%, and 10% in a decimal form is written as 0.10. And that was what you just collected and is in table 1, percent from your virtual lab. That's the 10 right there. And the surface area, so if you read up above, you went over research sites that were 100 square feet in area. So you're going to multiply that by 100 square feet. And so when you take care of it and you do all of the units, you end up with gallons of water. So 0.623 times 0.10 times 100 ends up being 6.23 gallons. And you're going to do that for each one of these. So you'll have to do the same thing here, the same thing here, the same thing here. And then, of course, the new percentages will provide you with a different amount of gallons for mountain versus bare soil. So what essentially stays the same is the 0.623 and the 100. The only thing you're changing is that 0.10 based on table 1. So in the case here, I would change this to a 0.25 and do the calculations and figure out how many gallons there are. Does anyone have any questions regarding any of this? This is a good time to ask. I'm always happy to answer. All right. So then the next part is you're going to look at the vegetation surface and does it affect runoff? Why do you think this happens? You can find that information that you need in your textbook and your resources like Muse. So does vegetation keep water in the soil? Does a mountaintop act a lot like a slide? Does the water go somewhere? So those are the questions that you're going to be answering. And see how it says using data from part 1? Do a comparison. Look at how many gallons that you have compared to, so if you're comparing vegetation and you want to compare it to mountain soil, look at how many gallons that you get. So there's only 10% runoff, and I put this in the wrong place. That's actually infiltration. So that should be here. I goofed. I didn't read it. So this should have been 25, and this one should have been 10. I don't know why we changed it, but anyhow, okay. So just look back to your tables and they will assist you in being able to answer these questions. The numbers tell you everything. Data tells you everything. So how is this graded? It's basically graded on understanding the water evaporation, runoff, and infiltration. Did you get the percentages correct? Then when you calculated it, did you get the gallons correct based on your multiplication? And then when you're doing your descriptions, are you using 3 to 5 sentences to answer all of those questions about data? And it says, you know, part of your points come in from using data from part 1. And the same is true for water loss, sediment loss on waterways, and soil quality. Any questions regarding that? Okay, so let's go ahead and jump back to our, let's see why it's not showing. We're going to jump back to, oh, where did it go? It's not allowing me to share anything. Oh, you guys can still see it already. Okay. Set up wrong. All right, so the first thing we want to do is, if you still have some of those strips that we made from week 2 on the pH strips, we can actually test the pH of water that you collect after a rainstorm. If you don't have rain after and you need to check water, you can check your tap water, see whether or not your water is on the acidic side or the alkalytic side. And if you recall back in week 2, we talked about pHs and 7 being neutral, and water is what we compare everything to. So water should come up at neutral, and you should not see any changes on your pH paper. And I used all the pH paper on week 2 for both classes, so I don't have any spare right now. So that's one thing that you can do. Another way to test the pH of something is we can actually use an acid and we can use a base. So I can actually take 2 containers here, and I'm just going to put a little bit of soil in them from my yard to determine whether or not these are acidic or they're basic. Okay, so I can take just plain old soil that I gathered from my yard, and I'll put it in there, and I'm going to put some in here. Okay, and I'm going to test it. So what am I going to test it with? So if I add a half a cup of distilled vinegar or distilled white vinegar to this, and if it fizzes, then that means my soil is actually basic. It's more on the basic side, and that would mean that my pH of my soil is actually above 7. If it doesn't fizz, then that means that my soil is acidic because I'm putting an acid in an acid, and it's going to be less than 7. Because remember, 7 is our baseline. So as we look through these, let's take a look. And this is where my white vinegar is coming in. Because if it's acidic, bubbling or fizzing indicates we had a chemical reaction. So I'm going to pour some of this in here, and we're going to look, and we're going to see, do I have any fizzing going on? I don't see any fizzing. And we can compare that by putting a little bit of water in there. So if we put water in here, it should look similar okay, so I have water over here as a baseline, and here's my acid. Since my acid did not fizz, it basically means that my soil is acidic because I'm putting like with like. So that's one way to test soil. Now, one of the things that you might be aware of or may not be is that soil has different compositions. It has sand, it has clay, it has what we call loamy soils. And so if I really wanted to find out what kind of soil I had, I could take my soil and I can dampen it. So I have a soil sample here showing the different layers that soil has, because you have your real sandy stuff, which is the stuff that I tested on the top here, and it sits on the top. And sandy soil tends to allow water to percolate through. It's kind of like a percolator if you've ever seen a percolating type of coffee maker. And what it does is it basically allows the water to go through the coffee grounds to create your coffee. That's what we call the percolator. Well, soil works in the exact same way. And depending on the composition, and when we say composition, we're talking about what soils are made of. And they're made of loose weathered rock, organic materials, and called silt, clay, and you can see them typically in 3 layers if you call a core sample. So I'm mimicking this with this here. And if I want to determine whether or not I've got a clay soil or a sandy soil, I need to actually grab it. And the indication for what we call the squeeze test to determine whether or not your soil from your garden is loamy or it is clay, more clay, is that it holds its shape when you give it a light poke. So that's more of like your clay, we call that kind of it crumbles apart because it's even bits sand, even bits clay, even bits rock, etc. If it holds its shape when it's poked and it just sits stubbornly in your hand, you have more clay. And what you really want is that loamy, luxurious type of soil, because if you have easy soil, no matter how you squeeze it and try to mold it, it continues to fall apart. And so it's kind of like Goldilocks and the Three Bears. You know, the porridge was too hot, the porridge was too cold, but the infant's porridge was just right. And that's what you're looking for in loamy soil. Okay. So although you're supposed to do this where it is wet, but not, so it should be kind of damp, but not super saturated. Okay. And I want to get something to put this on so that I don't make a mess. Hang on. All right. So if this is my parent material, and I take a look at this and I try to create a solid piece. Okay. If you notice that it's got a form. Okay. And if I set it down,
Professor had top,
and I kind of tap it, notice it doesn't crumble. It just kind of it sticks together and so on. So my soil here tends to be a little on the more clay side. That's what this is demonstrating, because when you squeeze it together, it really holds its shape. Okay. Now, I've got some soil here where I did a little bit of manipulating with it, and that's that parent material. Okay. So the key to having loamy material is when you touch it, it falls apart. So part of this is falling apart, part of it's sticking together. So that kind of tells you a little bit about whether or not your soil has more clay in it or it has more sand. So yeah, that's what we call the squeeze test. And now I've made a mess. And when my kids were young, we used to love to play in the mud. So that kind of explains that. Another test that you can do, which I can't do here because my soil is all wet, is called the percolation test. This is the one where you dig a hole about 6 inches wide and 1 foot deep. You fill the hole with water and you let it drain completely. Then you fill it with water again. And you time this, meaning how long or how fast does it drain out of the hole. And if the water takes more than 4 hours to drain, you have poor drainage, which means you have more of a clay type of soil. On the other hand, if it's less than 4 hours, you have somewhere between sandy and loamy type of soil. So I can't demonstrate that here, but you can do that outside if you're ever interested in doing that. Okay. You can also do what they call a mason jar soil test, but I won't worry about that. I've kind of given you guys some ideas about soil. So looking at my soil here, we're going to show how soil and water evaporation or water infiltration and sediment occurs. Okay, so what you want to do here is we're going to take, and I'm going to use sponges to demonstrate this. All right, so I have this first sponge here. This is what we would call a supersaturated sponge. The reason it's called supersaturated is because watch what happens when I pick it up. All the water is draining. This is part of what causes erosion during flash floods. Is when you have what they call supersaturated soil. Your soil just refuses to absorb any more water because there's just way too much. Okay, that's one example. So this is where your runoff would be excessive due to the fact that your sponge or your dirt can't hold any more water than it already has. Okay, So then we have the next example where, we're talking Goldilocks and the 3 bears. So we talk about something that's way too wet. Now, on the other hand, if you look at this sponge is representing dry, cracked dirt. Okay, so think Great Depression when there was no rain at all for months on end, and they ended up with sand, and they overplowed, they over-tilled, etc. And so what happens is when we go to try and get the water to absorb really fast, watch what it runs off the sides. I don't know if you caught that, but it was running off the sides before it actually was absorbed. That's another form of erosion. And if you have sand involved, it looks something like this, and the sand is carried away by the water, especially if you have a really fast flash flood on. So you pour it in there and you end up with the soil. Instead of absorbing, you see the water is running off and you have no absorption, and you've got soil being carried, which is why this is so cloudy. Okay. So then the final thing that might help you understand what we're doing is you can't see this sponge very well, but if you notice, I can squish it. I couldn't squish the other one that was over dry, but I can squish this one. And the reason I can squish this one is because it's not too dry, it's not too wet, and this is the one that represents what we call loamy soil. And this will immediately absorb the water. It's not going to until it hits the supersaturated state. And then it runs off because it can only absorb so much. So I hope that using the sponges gives you an idea of how soil works, and seeing soil, and I probably should have some sandy soil next time, but this should kind of give you an idea of what they're talking about when it comes to evaporation or infiltration. And infiltration occurs based on the type of soil you have. If it's really, really clay or full of clay, it's not going to allow the water to be absorbed into the rest of the area. On the other hand, if your soil is really sandy, it will percolate all the way through. And either way, that's not good for your plants either, because if it's percolating away and it's just running off the sides, you might as well just be on concrete and let it run down into a drain. All right, so I hope that this helps with the upcoming lab. If you guys have any questions, feel free to reach out to me. I'm happy to answer any questions. Other than that, that's all I have for you today. And I appreciate you joining me. Thank you so much. You guys have a great week, and we'll see you in the discussions and all that. You're welcome, and you're in Telepath.